Okay, so here we go. Next is the question that's already there, still on page 185. Something like this actually showed up on the provincial exam, almost exactly like this. Okay, so if you drive over the Louise Bridge or Redwood, right, you can see bridges that are built like this. And so there's just like a truss design, right? It's a bunch of trusses going diagonally and connecting. But you actually have triangles formed, right? I don't know if you can see that, right? There's a triangle here. There are also right triangles formed. So there's a bunch of triangles in there. But if you look at this one here, right? The question is asking how long is the bridge just by looking at this. If you look at this triangle right here, we're told that the two bottom sections are equally in length, like you're cutting this in two same sections, you're bisecting it, but in fact you have an isosceles triangle here, so you know that this is 11.3 feet also, right, because it's an isosceles. So how long is the bridge? What we're going to do is we know that on the side here, we know that the height of this triangle is 8 feet. So what we're going to do is take this out like that. We know that this is 8 feet. We know that this is 11.3 feet. Okay. Ira, we're on page 185, okay? So how would you solve that? Well, can I ask you to come up here, just so we're not too close? There, spread it out a bit. Okay, so we have two out of the three sides. We know that this is a right angle here. So we're missing the one of the legs, right? So you're going to know that you will have to take the square root of 11.3 squared minus 8 squared. And that is square root of 6369. And that is 7.98. Watch what I'm going to do. I'm not done yet. 9806. I'm going to use 4 decimals here. Okay. Using 4 decimals. Not done yet. I haven't answered the question. Okay. So what I need to do here, I've now determined that from here to here, it's 7.98, right? 7.9806. Yeah, so we just got to multiply it. So we have 1, 2, right? Like we can count how many sections there are, right? So they're all the same length, we're told. So 1, 2, 3, 4, 5, 6. 6 sections, right? Therefore, it'll be length will be 6 times 7.9806. I actually just leave that in my calculator and go times 6. That's 47.88, and we are in feet. So you can go feet or just put a tick. So maybe a note here. 1 tick means feet. 2 ticks would be inches. Just an aside. I know that I skipped it the first time, so I made sure I came back to it so that we can deal with it. Calculate the interior angles of triangle ABC. So where is ABC here? It's A, B, and C, which is the same as this one here, by the way. But we're going to just take ABC and write down what we know. Right? We know that this is 11.3, this is 11.3. We know that because it's the same as this triangle. Right? All these segments here that have one line across measure the same. So we know that part. We know this here, right? This measures x and this measures x. So really that section here would be 2 times 7.9806. That's 15.96 feet. Okay. Now this is an SSS, right? We use cosine law. Somebody joined. Can you just type here? If I don't know who joined. I just see the number. Okay, so we're gonna. Which one do you want to find first? If you have an option, always find the largest angle first. Where is the largest angle located? Across the longest side right here. So that would be A here. A, B is over here, C is over there. We know this is an isosceles, so as soon as we find that one, we will be able to find these two here because they measure the same, right? It's across the equal side. So cosine of A would be 11.3 squared plus 11.3 squared minus the side that's across from the angle you're trying to find squared. That's 2 times 11.3, 11.3. I'm just going to do it here because I will run out of room if I don't. I encourage you to run along with your, that's what you get there. It looks a little suspicious. I feel like I made a mistake, so I'm going to rerun that. No, it looks good. So cosine of A would be dividing these two. Using all decimals, so angle A would be cosine inverse of 0.0025. And that's 89.85 degrees, so almost 90. You found A. Angle B and C are found by just going 180 minus 89.85, and you will divide that by 2. But careful, this is in brackets always whenever you have that, even though it's not written. It's invisible brackets, okay? So that's 90.15 divided by 2. That is 45.08. Angle C is also 45.08. So now you found all the interior angles, A, B, and C of that triangle. Okay, Dylan, you're here? Good. on page 185, and now we're going to skip back to 200, okay? Page 200 from here. And if you're at home, and I told you you're here as well already, try to find this handout because we'll probably get to it later on, okay? Well, do you have this handout? So there's a stack right here behind you. It says ESMR4S. Those handouts I started handing out last week. So if you don't recognize one, just take them. So one from each slot. Okay, so go to page 200. And we're just going to quickly go over this and correct it, okay? Oh, that's even worse. There you go. Okay. So I asked you to solve for the indicated length or angle and classify, right? Identify the type of quadrilateral. So we talked about the quadrilaterals that, and that's, I think, on page 190, we wrote them all down. If you missed that, like let's say you missed that lesson, you got to go back to quadrilaterals a couple of days ago. But I can tell you that it's also summarized on 192. 192 has a bit of a flow chart, right? Quadrilaterals, they all have four sides, then you branch off to parallelograms, you branch off to rectangles, rhombus, and so forth. So, but I gave you my own version of this on page 190. Okay, so it's there. Just got to go look it up. Okay, so in this case, they wanted to know angle A. Okay, since you knew this is a parallelogram, we know that these two angles add up to 180. Okay, I told you that. Okay, so angle A is simply 115. Okay. Angle A is 180 minus 65. Angle A is 115. So you found that angle, and now we're going to classify it. It's slanted, and all four sides are equal in length. Therefore, this is a rhombus. Okay, not a square. This is the one that I looked back and I didn't tell you what this should be, but I think you can just imagine, right? PR is just the diagonal going across like this between P and R. They want to know what that length is. And since this is 5 centimeters, and you can tell this is an isosceles shape, right? It's a symmetrical shape, so you should expect PR to be 5 centimeters as well, right? Diagonals are equal, okay? And so we found that, and we can also say that this is an isosceles trapezoid because it has the two sides that are the same. And we also know that the base angles would be the same as well. We know that they're 60, but they didn't ask for it, so we're just going to give them what they need, okay? WX, right? WX, this is a kite, so there are two pairs of equal sides, so it's 1.5 centimeters. This is just a kite. L, they want angle L here. So this is a little trickier. Okay, here you got to be careful. So what you know about this triangle, you got to look around the whole thing. We know that this is 3 centimeters here, And we also, if this is 3, then this is 3 centimeters here from that end to that end, right? Because it's telling us this is a square. So by that logic, if this whole thing is 5 minus 3, this is 2 centimeters. Okay, so we're going to focus on this triangle right here. We know that this is 3 centimeters tall because it corresponds to this side. So we're going to take this little one out. We're going to do 2, 3, and this is 90. Okay, and we're going to figure out what this angle they want L, which is down here. This is L right here. We're going to figure out what this is. At first glance, we cannot do it. Okay, remember sine law, cosine law? You need a pair. You don't have one. So let's find this side here. We're going to call this x for now, and then we're going to have a pair. X is the hypotenuse, so x will be the square root of 3 squared plus 2 squared. X is equal to, you do some mental math, right? 3 squared is 9, and 2 squared is 4, so 9 and 4 is 13. Okay. Square root of 13 is 3.6056. We're going to round it to 4 decimals. Okay. Now you have a pair. Now we have a pair. By the way, Pythagorean theorem only works with right triangles, folks. Like some of you were trying on a test, we're trying to do Pythagoras on a oblique triangle, right? It doesn't work if it's unless it's 90. Okay. So now we have a pair, so we're going to go sine of 90 over 3.6056 is equal to sine of L over 3, because that's the side across from that. So sine of L is 3 times sine of 90, which is 1, divided by 3.6056. I'm going to continue here. Angle L will be sine inverse of whatever I get here. And that's 0.8320. Keeps going. So I'm going to use the inverse and get 56.31 degrees. So this one was a little bit more work than the other ones, obviously. And from time to time, we can expect that, right? So look at the marks associated with the question. If it's just a 1-mark question, like the top 3 there would have been out of 1. This one would probably have been out of 2, if not 3. Okay. Next page. This one, I actually find this interesting. You have to read and try to understand the question. Okay, that's the important part. Somebody joined, who was that? Just type here on the chat, okay? A farmer plans to build, we're on 201, to build an enclosure behind a barn between existing corrals. He wants to add a fence from point C that runs parallel to the barn, wall AB. So basically, this farmer wants to run a fence here from point C, and it's parallel, right? These are parallel to each other. Okay, this is the fence. Okay, and how can he ensure that the new fence is parallel to AB? How can he make sure that they are parallel? Well, do you remember? You kind of have to flip this on its side. Okay, this is looks like a right trapezoid. Okay, if this is 90, right, we know that this also has to be 90 because they have to add up to 180. If they don't, then they're not. Then it's not a right trapezoid. Okay, so this angle right here, okay, make sure this angle measures 90 degrees, comma, so that both add up to 180 degrees. And you can't see that, but now you can. Okay, that's how you would make sure these two lines are parallel. Okay, and it could have been any trapezoid. It could have been an isosceles trapezoid. That has to be there. Okay, what type of quadrilateral, what type will be formed by the enclosure with a new fence being built? It's a right trapezoid. And I'm going to add a C to this question. CC down there. I want to try to keep the whole thing on there in case you're copying still. C, determine angle C. And I'm being specific between corral number 1 and the new fence. Okay, Angelito, you're here. Determine angle C. And what I will do is I'll copy that one the way it is. This is technically C is up here, is right there. We know that this angle right here is 120 degrees, this one up here, based on the diagram above. So I told you that these two have to add up to 180, and which they do. We know that it's 90 and 90, right? What would C have to be if this is 120? Then this would have to be 60, right? Because it's the same on both sides of the quadrilateral, right? So angle C is going to be 180 minus 120, which is 60 degrees. So maybe what I will do is I will just go up. Yeah, write this down, and then I'll go up there. I put 180 on one side, but it's also 180 on the other side. This really tests your understanding of the concepts, okay? Let's go back up right here. And you know how I put 180 on this side? We will do the same thing here, right? These two add up to 180 as well. So it's these two and it is these two. Okay, so add that to your notes. And I'm gonna ask you to do this as well. Circle that, and we're gonna bring this down. And right here, we're gonna say or, right, make sure this angle is 60 degrees. Okay, so you could have either made sure this is 90 here, or you make sure this one up here is 60. But what you're after is that the sum of the consecutive angles here would have to add up to 180. So both ways are actually going to ensure that that these lines are parallel, because that's a condition for a right trapezoid. Okay. All right. We're good. Question 3. That's it for 2. Yeah. Then we're done with this part. Then we're going to do polygons. Okay. What is the perimeter of a this parallelogram? So perimeter, I don't know if you remember that, the distance around shape. Okay, that's what it is. It's the distance, you add up the distances around that shape. Okay, so parallelogram ABCD, so A, B, C, and D, they want that distance around. Well, we know that if this is 8, we know that this is 8. And we don't know these two sides. Okay, so we're going to figure out this one. I'm going to stick with this one. This is 2. This is 3. Didn't we just do a 2, 3? And this is CD, which we're going to call CD, right? Or you can call this X if you'd like. X is equal to square root of 3 squared plus 2 squared. X is equal to square root of 13. We just did one that is 2, 3. Yeah. That would be 3.6056. Let's just round to 3.61. That's okay. So perimeter would be 2 times 8, right? 2 eighths plus 2 times 3.61. Because when you found this x here, you actually found this side right here and this side right here. So that's how you find your perimeter. And you get 23.22 centimeters. That's your perimeter. And pay very close attention as to how they word things, right? I could have referred to X as CD and just use CD the whole time. Okay, notation, you have to be comfortable with it. B, what is the measure of ADC? Okay, ADC, so they want this measure right here. Okay, how would you do that? It's a little tricky here. What we're going to do is find a different approach. We know that this straight line here is 180, right? Like the full angle here is 180. We're going to go ahead and find this, subtract this measure from 180, and then get this angle inside here. That's the only way you can do that, because we know how to work with triangles. So we're going to figure out that angle right there. Okay, so let's go ahead and copy that down. Okay, so I'm going to just make part of the parallelogram here. This is 3, 2, this is 3.61. We're going to figure out this here. Let's call this angle X, right? And we know there's a 90 here, so we actually do have a pair in this case. We have a pair right here. Pair, that means you have sine law. Could you have used cosine law there? Right? You could. You could use cosine law because you have all three sides. So if you're comfortable with cosine law, go for it. It's longer. Some people prefer one over the other. It really doesn't matter. You might be off by a few decimals. I don't care. If you show me the work, it will work. Okay, so sine of 90 over 3.61 is equal to sine of x over 3, because we want this angle right here, which we also just did. 3 times sine of 90 over 3.61, and so sine of x is going to be 0.8310. Angle x will be sine inverse of 0.8310. Angle x would be 5620. Therefore, angle ADC will be 180 minus x. So angle ADC is going to be 180 minus 5620. That's 123.80. And we know it's obtuse. We know by just looking at it, okay? It's this angle right there that we're after. We subtracted x that we found from 180 because there's a straight line along the bottom to get that one right there. And that's the one they wanted, okay, not this one. Next, they want angle DCB, so just follow it. Start at DCB, the angle form, but C is going to be the middle. That's where the angle is going to be around. Okay, so let's go up and look at DCB, right? DCB, so they want this one. We know these add up to 180, okay? So all we're going to do is going to be 180 minus the one we just found here, the one that's at the bottom, 123.80. It's 5620, which we found earlier, basically. There we go. So, in a nutshell, we found that this is 123.80, and this is 5620, and they add up to 180 here. So they add up 180 here, and at the same time, these two, right, these two angles here will also add up to 180 always along a straight line. So there's two things here going on. They're actually all connected. Okay. All right. Next, I'm going to stop this recording because I want polygons to be separate.